To classes on organic chemistry, and today's class is general organic chemistry isomerism 1 and lecture number 13. And there will be 2 or 3 class on isomerism, and it is a very important topic for entrance, also for class exam point of view. And minutely follow, this is a very big concept. Until and unless you have original concept in isomerism, you can't proceed. And this is a very interesting chapter for me, and so also you will, for you also it will be an interesting one if you can understand the classes. And at the very beginning I tell you, you please subscribe the channel so that you will be in advantageous position, because for second year I will be uploading more and more entrance package which you will able to obtain it if you subscribe the channel. Anyway, isomerism, it is a concept. What does isomerism means? The organic compounds having same molecular formula differing at least in physical and chemical properties are called, very important thing, organic compounds having same molecular formula differing at least in physical or chemical or in both are called isomerism. Means they have the same molecular formula differing at least in physical and chemical properties, either in physical properties or in chemical properties or in the both. If such thing happens, then it is called isomerism. Now the classification of isomerism is a huge one, so you minutely follow how we can classify. First of all, I have classified, or you will get the broad classification is in 2 forms. One is constitutional isomerism, other is configurational isomerism. A lot of things here lies. Constitutional isomerism means there will be difference in the structure, and structures are a lot of differences, different in structures. And configuration isomerism in stereoisomers. Stereoisomers. What stereo means? In spatial arrangement, not related to spatial arrangement. This is a huge difference. This is constitutional isomerism, which is mainly concerned with structural isomers, and configuration isomerism is regarding to stereoisomers. And structural isomers, only difference in the structure. There is no concept of spatial arrangement, means it is not related to 3D configuration, it is related to 3D configuration. When 3D occurs, there is structural arrangement. So here there is structural arrangement occurs, and there is difference in the structural arrangement, that is called stereoisomers. And here you will not get any spatial arrangement, there is no 3D configuration is related to this one, hence it is called constitutional isomers. So there are broadly 2 types. One is constitutional isomers, another is configurational isomers. So I have taken constitutional isomers. This is chain isomerism, that may be called as skeletal isomers or nuclear isomers. Then positional isomerism, ring chain isomerism, functional isomerism, metamerism, and tautomerism or tautomers. Metamers, tautomers, metamerism, tautomerism. Anyway, one by one I will explain, but out of this you minutely follow. This is very elaborate and tough. Very often question is asked from this part, and this is a huge one. Mind that it will be very difficult for you to learn which one will give you position, which one give you chain, which one give you functional, which one metamers, what is. I will explain each and every one explicitly to give you the hints. How can you assume which one is. Now, so second part is again classified into broadly into 3 parts. Configurational means it is 3-dimensional, means it is stereoisomers, means it is related to space, where these are 3 types. Basically, optical isomers, conformers, geometrical isomers. Optical isomers related to chirality, chirality. Conformers related to rotation about single bond, and geometrical isomers rotation around double bond. You minutely follow this one, otherwise you will find it difficult in second year. Again, you will get this one. Conformational isomers I have already given in alkane chapters. So optical isomers, which is related to chirality optical activity, I will explain it later on. And conformers, which is due to the spatial difference in the spatial arrangement due to rotation along carbon-carbon single bond. Lots of arrangement will give, lots of conformers will get. This is conformation. Geometrical isomerism is generally restricted rotation around double bond. So one is from optical activity, from chirality, from dissymmetric chirogenetic center. Lots of things are there. Conformers through single bond and geometrical isomers through double bond. And all these three will give you configuration, means a structure which is three-dimensional structure in space, and there is difference in the arrangement of atoms or groups of atom in the space due to rotation through single bond, conformation due to rotation through double bond, and geometrical isomers, and due to optical activity for certain compound due to chirality or dissymmetry or chirogenetic center is called optical isomers. So broadly I have classified constitutional isomers and configuration isomers. This is related to space and this is not related to spatial arrangement. So a bit by bit, I am coming. Chain isomers, which is nuclear isomers, which is skeleton isomers. So that is nothing, very simple. I am not writing the definition. It is very simple. Just there is change in the structure of chain. So groups or atoms, carbon will be changed. That is from open chain, it will be branching, there will be change in the chain, and this is chain isomerism. Let me take one example, you can understand very easily. C6H5, simply write and you fill up with all this by hydrogen, you will get carbon 5. This is N-pentane. Am I right? This is N-pentane. And next one is very simple. You can write it yourself. Just change the chain. 2-methylbutane, you can write yourself. Next one is, this is neopentane or 2,2-dimethyl-propane, neopentane. So this is very simple. Chain, there is change of chain, there is branching. This is chain isomers, this is nuclear isomers, and this is skeleton isomers. Very simple. The next one is, one thing I have forgotten to mention you, just before proceeding to next of position isomers, function isomers, and Isomer isomers, let me explain a little, just you see. Because I have earlier told you, it is very difficult for you to understand from the structure whenever you will be given a molecular formula in concise form in the exam, and you will be asked to draw the all isomers, or you may be asked that how many isomers it will give. So it is very important for you to know how can you detect that which isomers it will show. It is very important and tough thing. So you see, if the configuration, if the formula is given or supplied to you in the exam is of the type CnH twice n plus O. I will give example. CnH twice n plus 2O means oxygen 1, and CnH twice n plus 2 hydrogen is double of carbon plus 2. Then it will give you, mind that, alcohol and ether. And if the configuration, if the formula is given like this, CnH twice n O, not 2, with the questions applied to you, molecular formulas applied to you, you can fit the formula, you can check the formula. This is very tough. It may give aldehyde, so that beforehand you can try which structure you can draw. It may be aldehyde, position of 1, 2, 1, 3, like this. So you can get different variety. One is aldehyde, 1, 2, 3, 4, 5, 6, 7. There will be 2. Am I right? 7 type. May not be 7 type, but I will give you example. But the possibility is that aldehyde, ketone, unsaturated alcohol means alcohol having double bonded compound means allyl alcohol type. Cyclic alcohol means cyclic alcohol. Ether, where is double bond but ether is there, epoxide and position. And this is very, very important one. You keep it in your mind. If it is this type, alcohol ether. If it is CnH twice n O type, so aldehyde, ketone, unsaturated alcohol and cyclic alcohol, ether and epoxides of many types, may be position 1, 2, 1, 3, like this. This is very important one. And if it is CnH twice n type, CnH twice n O2 type, O is 2 means acid, organic acid. If O is 2 means ester. If O is 2, then means another compound. You may get acid, you may get ester, you may get hydroxyl carbonyl 2. CO will be there, OH will be there in the compound. And if it is CnH twice n minus 2 means alkyne, you will get only 2 alkyne alkadiene. These are the things beforehand you should know. Simple, CnH twice n plus O, there is only one possibilities, alcohol and ether, nothing else. I will show you with example. CnH twice n O, and lots of possibilities there. Very often question asks from here, aldehyde, ketone, unsaturated alcohol and cyclic alcohol, ethers and of double bonded compound, ether with double bond, epoxides with different positions, 7 types. And CnH twice n O2 is equal to alcohol, acid and ester and carbonyl with hydroxyl, and CnH twice n minus 2 alkyl and alkadiene means triple bond and double bond in 2 places. Am I right? Position isomers, it is number 2. Am I right? It only the position of the functional group will change. If double bond is 1, 2, it may go to in 3 position. If OH is 1, it may go to in 2 position, 3 position. If chlorine is 1, it may go to 2 and 3 position. So there is change in the substituent or atoms or group. Group will change in the chain. So let me take an example to explain position isomers. So C3CH2Cl2. Am I right? So in a very simple way you can understand, it is not tough. Or yes, at that point I will explain another thing. Immediately follow C3H6Cl3. We will get 4 types of isomers where the chlorine, the halide is changing. Just I have arranged chlorine in 2 position in 2 position in carbon 2 dihalide or dichloro 1 to 2 to dichloropropane. Like this, I have now again changed. I have taken the chlorine in this 2. I have taken the chlorine in adjacent 2. I have taken chlorine 1, 3 positions. So position has been changed. So it is positional isomers. Say CH3 CH2OH means C2H5OH. You are asked in exam, very simple one. So I can write C3H7OH. So here this is one type, and you see the position 1 2 3 or 1 2 3 1 position is 2. Just I have changed the position function group. This it is also positional isomerism. So one of the very sometimes in exam you are confused in entrance exam with the question that regioisomers are nothing but the structural isomers where the functional group changes in different position of the carbon are called regioisomers. These are nothing but position isomers, but the new name is given regioisomers where the functional group changes from one position to other. So another name of these position isomers are called regioisomers where the functional group changes from one carbon to the another. So regioisomers are nothing but position isomer. So it is one of the another name of regioisomers. Sometimes you may given say but 1 in, maybe but 2 in, but in one position double bond, maybe in middle position double bond. So double bond position has been changed. Again it is regioisomers. Functional group position changes. So we have not till got any complexity or difficulty in isomers. Bit by bit will come. Now we are coming to very important one and very tough thing. I think it is tough. You minutely follow and lots of examples I will provide. This is functional isomers. Functional isomers appears due to change in nature. One of the important thing I have told you, change in nature of isomer. This is very important. You should learn the definition of functional isomers, because this definition here is important because of the fact that position isomers and functional isomers very often students like you may be confused. Position means functional groups or the groups of groups or atom may change from one carbon to another. That is functional group changes. But here, due to the change in the nature of functional group, what does it mean? Change in nature means once it is CHO, others it is CO, other time it is ether. That functional group is going to be changed. If functional group remains same and takes its position in different time in different place, then it is position. But if some functional group goes on changing, so its nature will change. So functional group nature will change, and that type of isomers are called functional isomers, and this is very important one. At the very beginning, I told you C and H twice and O, and I minutely follow. This is very important. Let me take one example. So you see, first of all, you see CnH twice n plus 2 means 4, 4, 2 is equal to 8 plus 2 CnH twice n plus n O. So I have taken example C4H10O, and at the very beginning I gave you this some tips that when you will get CnH twice n plus O type, you will find that either it is alcohol or it is ether. Am I right? So I will change it into alcohol and ether. So that's why you can first predict what kind of isomerism it may show. So I will compare this molecular formula supplied in exam with the formula CnH twice n plus 2, CnH twice n O2, CnH or like all the formula I will check. If I find this is CnH twice n plus 2O, I will say it is either alcohol or ether. It will show only two isomers. So first one is CH3, CH2, 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 OH, and CH3, CH2, O. Set. I told you that it will give you alcohol and ether, so it is ether. O is there and it is alcohol. Am I right? So CnH twice n plus 2, in short, I have shown you of two types of isomers. It will show. Now let me come to the more complicated one. Type CnH twice n O. I am again giving asterisk mark. Very tough. H6O. So if you recall, I told you that CnH twice n O, I gave you asterisk earlier. It may show aldehyde, may show ketone, unsaturated, alcohol, cyclic, alcohol, ether with double bond, epoxide with positions. Blindly, you can tell that it will give you 7 type of isomerism you will never expect. One by one, I will write and I will show. First one is aldehyde. So let us write CH3, CH2, CH. This is aldehyde group. Am I right? So 3, 5 and 6. Am I right? Number 2, what I told here is ketone. Ketone group is here. Again 3, 3, 6. Everything okay. So second one is unsaturated alcohol, means allyl alcohol. Next one is cyclic alcohol. Next one is ether. And that must contain double bond. Am I right? Am I right? 3 to 5 and 6. Am I right? So this is vinyl. Am I right? It is vinyl. So methyl vinyl ether. Methyl vinyl ether. So 5 type. Am I right? Now let me come to the 6th one, epoxide. Am I right? Epoxide. And another, when I told you epoxide, there is change of position. So 1 and 2 there is O. If I take 1 and 3 in between this O, so I can write propane. So very simple formula, C3H6 and O has been given to us. Until and unless we can predict that it is CnH twice and what there is possibility of aldehyde, ketone, unsaturated alcohol and cyclic alcohol and ethers with double bonded compounds and epoxide with different position. We can't explain the 7 type of us. Never expect 7 type of sorry isomerism. It can show with C3H6O. So this is very important. You minutely follow which formula it follows. Am I right? C3H twice and O2. And I have told you that it will given where there is O2 means O is 2 number. O is 2 number oxy and carbonyl group. So let us take an propanoic acid 3 to 5 and 6 and oxygen is 2. So one is acid. Am I right? Other is ester. Let's see how we can write ester. This is ester group, oic acid group. So we have got 2. Now what is the third one? So carboxyl, hydroxyl and carbonyl. Hydroxyl and carbonyl. COCHO. COH. C double bond OH. So we have, and also we can get So with CnH twice and O2 means etc. We may get acid, ester, aldehyde, all, and ketone, all. Hydroxy, OH, ketone, carbonyl. Am I right? So this is the type CnH twice and O2. We have got 4. So until and unless you can understand, you can fit this formula with this one, you can't imagine which one. You must know which formula will give what type. Otherwise, you can't give in a ready-made way. If you solve out a lots of competitive exam question to get isomerism, if you do not have the real concept, you can't distinguish which one will give what type. I have written one more carbon. This is type 1, and it will show alkyne and alkadiene. So diene means to die. So this is the two type, very simple. One is alkyne, this is alkyne, and alkadiene. But 1 diene. Next one is nitroalkane and alkyne nitrite. Means one is nitro and other is ONO, nitrite. So let us take example 6H5 NO2. So first type is CH3CH2 NO2, and second type is, or you can write NO in the form, am I right? And other is very simple, alkadiene, nitrite, CH3 CH2 O NO. So this is nitro and this is O2 alkyl nitrate ONO. And in second year again you will get this C3H9N. When you will get amine, in the first attempt you will write this structure 1 degree, 2 degree, 3 degree. First one is very simple, CH3 CH2 CH2 NH2. Am I right? 1 2 3 5 6 7 8 9. Second one is here you are getting here 2 degree. Now two aminopropane. Am I right? So totally we have got 4 types of hybridization, isomerism with C3H9 and 1 degree, 2 degree, 3 degree very easily we have arranged, and third one just to have changed the position of N2. So this is some isomers of amines. Mind that here C2H5NO, not NO2. If it is NO2, it would have been nitro and nitrite. Am I right? So it is NO, not O2. Here I have written the oxime. Whenever there is a question of oxime in Beckmann rearrangement, in the last rearrangement classes I have given you Pinacol rearrangement, Beckmann rearrangement, and Hoffman rearrangement. These are the very important things, and those who will appear in the final exam, they need not watch these 3. They discard these 3 because these 3 are meant for the entrance exam. So here at that class I mentioned oxime. Oxime means C double bond NOH. If there is a structure, there is C double bond NOH is there, then it is oxime. So we have seen that from this structure we have C double bond NOH is oxime. We have got oxime. And another amide group is CONH2. Am I right? So we will write CH3. Am I right? Acetamide, aldoxime. So we have got only two isomers. One is oxime, and other is amide. So oxime and amide are the two isomers. Next one is very uncommon, and very often you won't get this one for entrance or other classes. You can see such kind of C6H12. There you will get ring chain isomers. Means there will be ring, there will be chain. So there will be ring. So ring means it is carbon and hydrogen number is double, means cyclohexane, and also you can make it methyl cyclopentane. So you have got two. Another is this. So you are getting ring, cyclohexane, ring, and you are getting chain. But often you will find that if you write only one hexane type, so means that yeah, hints is that why I have brought here double bond, because CNH twice N is there. So somewhere I will give a double bond. So this will give you, I can change the double bond. I can write a lots of change. I can make a lot of change here. Am I right? So a lots of different isomers I may get. The primarily will get ring, and chain. By changing this position of the double bond, again you will get another type of isomers. So ring chain isomers, generally ring to chain, that will show ring may increase, may decrease, and there will be chain. So this is all about the isomers. And besides, for tomorrow or next class, I am going to start the very important one is metamerism and tautomerism, because and lots of questions are often asked from this to one, and many of you do not have profound knowledge on metamers or tautomers, and these are very important because in reaction mechanism also tautomers occurs, and I will explain details on metamers at my next class. Thanks a lot for watching the class. Now, I hope you have enjoyed the class.